Okay, I thought I would take a few minutes and go over some important concepts covered on the test and talk to you a little bit more about the type 1 and type 2 errors and power of a test. So this is your test review for chapters 21 and 22. I'll kind of just page through this real quick. You'll begin with independent or dependent samples, and then the description of a dependent sample. Then you'll be talking about qualitative or quantitative response variables, and then, of course, the dependent or independent type of sampling. And you should be pretty good with those. Let me know if you have any questions after you check your answers. Then you will be constructing confidence intervals, and that will be throughout this review. Also here coming up with sample statistics, so finding Z from the test. There's some more confidence intervals. There we will be finding the correct alternative hypothesis, finding HA. And then conditions. So I might want to highlight number 14. Make sure you read through number 14 and understand the correct answer. And I'm going to point out one more similar to that I want to make sure you understand what that is. There is a conclusion of a hypothesis test. And number 16, what a p-value represents. And in number 17, running that to proportion test. And in number 18, there you go, choosing the alternative hypothesis again. And this is number 19. I want to make sure you read through that and you understand each one of those choices and the correct answer. Now, part of this video, or the main reason I'd like to make this video, is to discuss number 20. And as you can see, 21 and 22, they do talk about the errors. There's type 1 and type 2. So 20, 21, and 22. Guess I should highlight those. And also 23. And here in 23, we're talking about the power of a test. So what I want to do is I want to go ahead and explain some of these things and have you go back and try to work these with this explanation. And then, of course, let me know if you have any problems. 24, 25, 26, and 27 are all tests where you will assume the conditions have been met. What's the good news about that? You're just going to go ahead and state your hypotheses. Then you'll go ahead and give your p-value and then a good conclusion. And that conclusion should state what your decision was because of that p-value that you found, okay? And that'll be for those through 27, okay? So on this page here, I thought I would go ahead and go through a table. And this table is actually going to have to be completed on your test. So let me just make a big rectangle here, and I'll go ahead and have 4 quadrants. And I'm going to go ahead and explain a little bit here first. So in this table, we are going to have the null hypothesis is true, and then the null hypothesis is false. Now keep in mind that this is the truth, and sometimes we don't know the truth, but it's actually what is true. This top row, okay? Now let's look on the side of this table, and first we're going to have reject the null hypothesis, and then do not reject the null hypothesis. And these are what? These are your decisions. So I'm just going to put my decision. And this is what we decide to do. We either reject or we do not reject. Okay, so how are we going to come up with filling in this table? What I'm going to be asking you to do is to tell me which one of these decisions is a type 1 error, which is a type 2 error. Hope I didn't write too big here. And then what about a correct decision? And let's make that a little bit smaller. And we actually are going to have 2 correct decisions. So now let's take a look because we have 4 spaces. Let's begin with the correct decisions. So what if the null hypothesis is true? Let me use a different color. What if the null hypothesis is true and we do not reject it? So if we do not reject a null hypothesis, that's correct. We want to leave the null hypothesis alone. So that is a correct decision. So not rejecting a true hypothesis. Okay? Now let's go to the next area. What if the null hypothesis is false and we do reject it? That's a good decision. It's a good decision to reject something that's false. So now we can go ahead and place our correct decision here in this next area. Okay, now we need to talk about our errors. We haven't made an error if we reject a hypothesis when that hypothesis was true. So we have something that's true and we're saying, nope, we don't want it. So that is definitely an error, and that is a type 1 error. And we'll talk about what these values are. So that is a type 1 error when we reject a true hypothesis. And of course, there's only one place left for our type 2 error, and let's talk about that. Our type 2 error occurs when the null hypothesis is false and we don't reject it. A false null hypothesis needs to be rejected, and we did not reject it. So that is a type 2 error. So now, I hope that helps. Now, probably one of the most important things to us is something called the power of a test. What is that power? And the power of the test is 1 minus beta. And that needs to be known. It's not 1 plus, it's not beta minus 1, it is 1 minus beta. Well, you might be saying, well, where is that? Where is that in our table? Well, obviously, power is going to be a correct decision. And let me tell you, it is this correct decision that is our power. And it's so important, I'm even going to write the word power there. So the power of a test is when we reject a null hypothesis that was false. A null hypothesis that was not true needs to be rejected. And that is what we call the power of our test. Okay? So if that is 1 minus beta, you guessed it, a type 2 error is beta. So if you can just remember our correct decision as 1 minus beta, because these columns need to add up to 1. Okay? So why did I include that little bit of algebra? 1 minus beta plus beta is equal to 1. Okay? So you might be thinking, well, what about this alpha? Where did this alpha come from? Well, alpha is actually a type 1 error. And you're not going to believe this, but but this is the alpha that you have been stating every time you run a test or an interval. You say let alpha be 0.05 or alpha is equal to 0.01. That is something that we test, and that is actually use in our tests, and that's actually a type 1 error. Most don't discuss this, but the correct decision is actually 1 minus alpha there. I always like to put that on the table because I like to have everything nice and even. But I just really thought that this might help you. So now let's talk about how and what affects the power, because that's usually what the questions are about. So in any university level stat class, that's a big deal. So let's write a few things down. The first thing I want you to know is that let's write down power is equal to 1 minus beta. So let's just discuss this. If beta goes up, what happens to the power? That's correct. If beta increases, the power decreases. So maybe I'll make little bullets here. And you should be able to see that algebraically, okay? And I'm just going to keep power up here. Okay, let's talk, and we do want the power high. Our goal is to have a high power. We want to reject a false hypothesis. That's our goal. That's the power. Okay. Now, let's talk about alpha. There is a relationship between alpha and beta. Okay? This isn't talked about very much, but this is how I always remembered it. When alpha goes up, beta goes down. So, when alpha goes up, what happens to the power? 1 minus beta, which is also the power, what happens to that? It also goes up. Okay? So you just have to kind of think through each one of these. Hopefully this is helping a little bit. And now let's see if there's anything else. I think it's important to note that whenever we increase our sample size, things always get better. In fact, I'm just going to put always gets, I better not put always gets better, but things just get better when we increase our sample size. We have more accuracy. So what do you think is going to happen to the power? If the sample size goes up, our power of our test also goes up. Okay? What about if we decrease our sample? You guessed it. That power is going to go down. So what are you thinking now? What if someone asked you about a relationship between the sample size and beta? Would you be able to answer this? If the sample size increases, what will happen to beta? Think about that for a minute. If you have to pause the video, that's fine. So if the sample size goes up, beta will go down. Okay? So I really think that should help you quite a bit. We have, let's see. One other thing I want to talk about is a two-tailed test. This doesn't come up very often, but I will make a note that when you change from a two-tailed test to a one-tailed test, what happens? That P is divided by 2. That P value is divided by 2. Therefore, when that happens, that power goes up, which of course beta is going to decrease. So I do think that this might help you. I will tell you that the sample size does need to be fixed on these little scenarios over here on the right. Here, you have to have a fixed N. You can't be changing beta and alpha and also changing the sample size at the same time. So these little comments I have here is when n is fixed and not changing. Okay, so I think that probably will help you answer some of these questions, especially, like I said, this in a hypothesis test, when we increase alpha, does that decrease or increase the power? That's a good question. What is a type 1 error? Think about that. We're making an error, so it is either, one of these is either rejecting a true hypothesis or not rejecting a false hypothesis. Those are our errors. And here's another one. In a hypothesis test, which of the following will cause a decrease in beta? So keep in mind, if beta goes down, that power is going to go up, and that's what we want. So go ahead and think through that. And I think that might be it. I did give you this relationship between alpha and beta. This has always been of help to me. I just always remembered that alpha and beta were opposite. When alpha went up, beta went down, and vice versa. And of course, you can tell when beta and the power are related. So the best of luck to you, and let me know if you have any questions.